All right, so section 2, we're going to graph equations that look like that top equation, ax squared plus bx plus c. Now I have the same thing on the sideboard, so as we work through this stuff, we can look either place in terms of our instructions and walking through. Key ideas. Identifying the number here, the number there, and the number there for those values of a, b, and c. Sometimes it'll be 1, 0, and something. So you're always looking for what's in front of the x squared, what's in front of the x, and what's the number at the back. Those three numbers influence and make the graph shift, change, flip, spread wide, be skinny, all those kinds of things. Yeah. Exactly. And today we're doing a full quadratic equation. Now, you all are aware of the fact that a parabola looks something like that. And you're all aware of the fact that right down the middle of that parabola, there's that dotted line called the axis of symmetry. Now, yesterday, all of your graphs were where? Side to side. They were right on the y-axis. Notice where I drew this one. Is it on the y-axis? No, it's off. But, Ryan, if we look here, this point is always going to be symmetrical to that point. That point there will always be symmetrical to that point. And so, if we have half the graph, we can flip across that dotted line and get the other half very quickly. Okay, so that's going to be a huge time saver for us in flipping that graph. Now, right here, this right there is the most important part of what we're going to start with today. That is the equation for that dotted line. Everything focuses on that dotted line, that axis of symmetry. And so once we identify the values of a, b, and c, everything focuses on that axis of symmetry. So let's look down at example 1, and we'll refer to the sideboard or our notes up here in terms of our steps to go through. But all we're trying to do is show you how to get 5 or 6 points to accurately graph the parabola. You sketch it and you're done. So here we go. First one, 2x squared plus 4x minus 3. Anybody need a pencil, by the way? Do you know? All right. So let's put down the values of a, b, and c in the box. Pretty simple. Okay, a is 2, b is 4, c is negative 3. Now from yesterday's tendencies, without thinking through much at all, does this parabola go up or down? It goes up. Is it normal, fat, or skinny? It's skinny. Good. Why? Yeah, the number's higher. That's great, Grace. The number is higher. That 2 is what causes it to be skinny and go up. All right, so here we go. Now, every time you do this on your homework, I would encourage you to write down the formula for the axis of symmetry, the opposite of b over 2a. And now I'm just going to plug in the values for x. Negative 4 over 2 times 2, that's negative 4 over 4, or negative 1. Did I go too fast there? That makes sense? I'm just plugging in the values to find out that number. Now remember, that's a dotted line. Dotted lines means they're reference lines. They don't really exist, but they're definitely reference lines. So everyone draw a dotted line at negative 1. So is this parabola on the y-axis? No. It's shifted a little bit left. So all the symmetry, Noah, is not going to be right across the y-axis. It's going to be a little bit left. All right, so second point. Somewhere on that dotted line is the bottom of the parabola. That bottom of the parabola is called the vertex. So on that dotted line, we know that the vertex has a point negative 1 comma blank. Where do I get that negative 1 from? Because it's on the dotted line. So if you're not sure, put a little arrow like that to say, oh, that's where that comes from. Well, now I just plug it in. Here we go. 2 times negative 1 squared plus 4 times negative 1 minus 3. Negative 1 squared is 1. 2 times 1 is 2. 4 times negative 1 is negative 4 minus 3. Where am I getting these from? These are all the x's from the equation. So I took this negative 1 value right here, x equals negative 1. I plugged it into this equation right there. Bada bing, bada boom. And what does that work out to? Yeah.
Why would you times 3
Well, I'm coming back up to this original equation of the parabola. So if you look, I probably should have rewritten this. This x squared got replaced by negative 1 squared. This x got replaced by negative 1. And
It's just the x.
right, exactly. It's the x's from the equation.
Why didn't you just place the negative 3 in the floor?
Why did I place the what?
Oh, yeah.
Because we have to find out where it is. So it's negative 5. So go to your line, go down to negative 5, 1, 2, 3, 4, 5, and put a big dot there. That dot is the anchor of the parabola. That's the vertex. Everything comes off of that point. Now, Grace told us at the beginning that this parabola goes which way? Up. So just got to keep that in mind. The next step is the easiest step of the entire part. Where does it cross this dark y-intercept line? This is so simple. Right up here it says find the y-intercepts. It's the value of C. Zach, question?
How do you know it's going up?
How do I know it's going up? Grace, can you come back and explain that? Yeah, that's right. It's because it's positive. If the number in front of the x squared is positive, it goes up. If the number in front of the x squared is negative, it goes down. Does that help? And that was kind of from yesterday, the idea of max and min. So, all right, the y-intercept, coming back down here to the bottom, is 0, comma c. And when I say c, I'm speaking of the c value in the equation. So that is 0, comma negative 3. That make sense? So let's plot 0, negative 3 on the graph. Boom. Now, mirror it. When I say mirror it or flip it or reflect it or anything like that, if we're one to the left or one to the right, just flip over the other side, and you're going to end up just there. So flip it now. Now you have 3 points. Boom. Does everyone see how I flipped that? Here I went, since it's one away that way, it's one away that way. All right, now I need at least another point. Well, we have to be very careful in our choices. We want to choose something that's close to what we're working with, because if we choose it so far away, it's going to be way off the graph. And in the same way, I like easy. Do you guys want to choose negative 3 or positive 1 for ease of use? I'm always going to go with my easier methods because I know I make mistakes with negatives. So choose something that's close. And so I made you a little table down here. So you said positive 1. Yes, sir?
If we use 0, would we just get the y-intercept?
You would. So that's why you don't use 0. You can't use anything you already have. And so we're not always going to use the same point here. So let's see. That's 2 plus 4 minus 3. So that's 3. So that's 1, comma 3. 1, 2, 3. That's my 4th point. Is it easy to get a 5th point? Just do what? Mirror it, flip it, reflect it. Boom. And I think that's enough to sketch it. Remember at the bottom, what's it supposed to be? A U. Sometimes that's hard when they're skinny. And remember at the end of your parabola, what do you need? Arrows. Because there's more off the graph than there is on the graph. Now let's just review what we did. Step 1, A, B, and C. On your homework, Brett, I would make a little box and put A equals B equals C equals. When people have done that, they typically don't make mistakes. Axis of symmetry, we drew that dotted line. On that dotted line is the vertex. We used that point, plugged it in, found the y value, got the really easy y-intercept, flipped it, found one more point and flipped it. Why don't I need down here? Because I already have 5 points and that's plenty. All right? Yeah.
So if you only have 2 variables, it would be easier to find the vertex because there's the y-intercept.
Right. That's because all the b values were 0. So, but not today. We're trying to be as general as possible to kind of teach you a big picture. Now, this may seem like it's a little exorbitant or whatever, but I've done one problem on an entire page just so we can spread our work out and have plenty of room just to kind of work through this. All right, who can give me A, B, and C? Jalan, go. Good.
4, -4.
All right. Someone make me a conclusion. Where does this thing go? Am I going up or down? Down. Okay, so if it helps right here, make yourself a little note. It goes down. And Grace, once again, why does it go down? Because it's negative. Excellent. All right, Jalan, question? Yes. All right, so here we go. Axis of symmetry. Without looking back at the previous page, does anyone remember the equation? Luke?
Negative x over 2a.
Close. Opposite of b
Negative b.
over 2a. All right, so go ahead and plug that in. Negative 4 over 2 times negative 1. What's my value, guys?
No, is it just 2?
Is it 2 or negative 2?
Just 2. 2.
Just 2. Okay, put a box around that. Now I get to draw. Okay? On that vertical line is the vertex. How much of the vertex do we already have? We have half of it, right? 2 comma blank. Where did that 2 come from? That x value. So let's plug it in. What do I plug it into? The equation. So here we go. Be careful here. The opposite of 2 squared plus 4 times 2 minus 4. Be really careful as you think through this. Are you squaring 2 or are you squaring negative 2? You're squaring 2. So Ryan, be careful as you work this one. That's going to be 2 squared is 4, so it's negative 4.
No.
Yeah.
That's one thing I was confused on. If you have like a variable and there's a negative in front of it and you're plugging in the number, do you always just leave
Take the
it
opposite of whatever it is. Unless you're squaring it, then you square it first.
Do you always leave the negative on?
I leave the negative out and I do that at the end. So I have negative 4 plus 8 minus 4. That looks to me like it's what? 0. So plot the point 2, 0. All right, easiest point on the graph. 0 comma c. What's my value of c?
Negative 4.
So 0 comma minus 4. Does it look like it's going down? Yeah. Now, I'm 2 away from the dotted line. So where's my reflected point?
2a.
2 away. So flip onto the other side this time. Yes, sir?
Well, the y,
Uh-huh.
isn't it? How do you get negative?
How do I get negative 4? The value of c.
All of the value of c.
And where does c come from?
What's the y? What goes through the y then? Y equals 0.
Just right here?
Yeah.
That 0 came from figuring out this value here when we plugged in the number 2.
Oh, is that the one number 14?
Yeah. So that's kind of vertex section, axis of symmetry section, so to speak. All right, I need one more point. What can't I choose? I can't choose 0, I can't choose 2, and I can't choose 4. You want to choose 1? Okay, we'll choose 1. 1's easy. So I'm going to slide it up here. 1 negative of 1 squared plus 4 times 1 minus 4. Someone work that out for me. What'd you get? Yeah. negative 1. So we have the point 1 comma negative 1. Did I go too fast there? I just worked this out. So now I come back up to my graph. 1, negative 1. There's my fourth point. Justin, is the fifth one pretty easy? Okay, let's flip across. Boom. Is that enough to give a decent shape? Okay, let's draw it. All right, as Grace predicted, it goes down. We have the y-intercept, we have the vertex. If I asked you on the quiz on Friday, is this vertex a max or a min? What would you say? It's a max. Do you need to graph it to know that it's a max? No. You can get the fact it's a max just by the fact that A is a negative number. All right? So, obviously it's spread out just so we have plenty of room to write. Let's take a look at the next one. I tried to pick different equations that had different characteristics as we practice through these. All right, Hannah or Abby, give me my A, B, and C. A is a half. Okay. Without looking at the sideboard, someone in that section over there, what is the axis of symmetry equation? Sydney.
-3 over 2a.
All right, opposite of B over 2a. So let's plug it in. The opposite of 2 over 2 times a half.
-2.
-2? I always like to box it because that isolates and goes from there. All right, so I'm going to draw it. I love drawing these. Dotted lines are fun. Somewhere on that dotted line is what? The vertex. All right. Someone besides Grace, tell me, does this thing go up or down? It goes up. Is it normal, skinny, or fat, and why?
Fat.
Why?
Because it's a smaller number.
Smaller number. Okay, it's a little bit fatter, so this one's going to be a little bit wider. Is it going to be really wide? No, a little bit wider. All right, so let's find that vertex. V, negative 2, comma blank. Here we go. 1/2 times -2 squared plus 2 times -2 plus 1. Abby, you see where I'm putting those numbers in from, that equation? I come up here, to this equation up here, that 1/2 x squared, and I took this value of -2, and I just stuck it in for the first x and the second x. All right. Think with me here. -2 squared is how much?
-4.
Uh-uh.
Or
Positive 4. What's half of positive 4? 2. Right? So we have 2 minus 4 plus 1. 2 minus 4,
You get -1.
-2 plus 1, -1. So, -1. So plot that.
What was the y equals on the vertex for reference row?
Okay? You got it. All right. Y-intercept. 0, comma C.
1.
0, comma 1. All right, everybody flip that. Flip over, put your dot on. How far away from you the dotted line? 2 away, so flip over to the other side. Is it going up? Does it look fatter than our other ones? Okay, so we're in good shape. Now, question. I've got a pretty good idea of how the curve is going in between these points so far. Would it be better to choose a point on the inside or a point maybe out here? Probably. How far out do you want to go?
Like
6.
You go out 6, you'll be off the ground. So you got to, I'm probably going to choose something either 1 or 2. 2. 2? Okay, let's choose 2. All right, slide down here to the bottom. Now, is it wrong if you choose something in the middle? Or what? No, we're just trying to get a basic shape. Shape. 2 squared, 2 times 2 plus 1. Let's see. Half of 4 is 2. I get 7, is that right? I hope I'm on the graph. 2, 1, 2, 3, 4, 5, 6. Yes, I made it. Okay. 2, 7. How far away is that from the dotted line? It's 4 away. So go 4 the other way. 1, 2, 3, 4. Now, does that give us a pretty good shape? Question. How do you feel about this graph? Does it feel really wide or just a little bit wide? Pretty wide? Okay. Just to compare, okay, here's 1/2 x squared, here's x squared. Are they pretty close? Half x squared, 1x squared. A little bit wider, but not much, right? Okay, moving on. Hypothesis. This graph goes up. This graph is skinny. Good. Why, Luke? It's a bigger number. Okay, so we can just put skinny and up. So as we're working our problem, we're just looking for something that's skinny and up. All right, A, B, and C. Mr. Switek, please. All right. Equation for the axis of symmetry. Mr. Albaugh. Excellent. Here we go. Let's see. -6 over 2 times 2. -6 over 4, which is -1.5. Is it possible to have an axis of symmetry that's not on a nice neat line? Yeah. And that's why we're doing this example, just to show you what happens when it's there. Okay? So draw a dotted line at -1.5. You might want to have your calculators out for this next step. The vertex, -1.5, comma, blank. Now I'm going to write this out, but we may need to use our calculators to get it because it's going to get messy with the decimals. Okay, so let's plug that in. 2 parentheses -1.5 parentheses squared plus 6 parentheses -1.5 close parentheses minus 3. Check me on this. I get -7.5. Can someone check me?
Yep.
So we're good, -7.5. One, 2, 3, 4, 5, 6, 7.5. And Luke told us, which way did this thing go, Luke? Up. And it's skinny, right?
Yeah.
Okay, y-intercept, Luke. Can you tell me what the y-intercept is?
0, -3.
0, -3. So let's plot that. Now, when I flip this one, how far do I flip it over the dotted line? 1.5. I don't flip it 1 or 2, I flip it 1.5. So where am I flipping to? Negative 3. All right, Justin, you got that frame? You see how it's skinny? Do you want to choose negative 1, negative 2, or do you want to choose 1 or 2? Okay, which one? Which one's easier for you?
1.
Okay, so I'm all into easy. Let's choose 1. 2 times 1 squared, 6 times 1 plus a negative 3. 2 plus 6 minus 3. I get 5. Is that true? So 1 comma 5. 1, 2, 3, 4. I'm afraid, Justin, if you had chosen 2, what would have happened? It would have been off. So when in doubt, stay close. All right? And flip across. Ooh, this is a little bit challenging to flip. How far are we from that dotted line? 2.5. So there's a half, 1, 2. This one's pretty steep. That's a very steep parabola. So it's really obviously a big difference between what we had and what we had before. Yeah.
Can you read the straight graph?
Sure. Notice how I said fourth or fifth point at the bottom. Do we need another point to frame this? All right, let's look at our last example. Suppose a ball is thrown in the field house from a starting height of 4 feet. In other words, I'm holding a ball at about my waist. And I throw it initially upwards at 66 feet per second. That's moving. Okay? How long will it take the ball to reach the top of its arc? And when it does, how high will it be? No, it's like applied math. That's what physics is. That's why I love physics. All right, now I'm going to give you some information. I'm going to give you the equation of this ball. Here's the equation. And because I want you guys to be good people, in terms of understanding, I need to show you some things about this equation that you need to know. Do you guys know and are you aware of the fact that gravity is 32 feet per second? Has anyone ever heard that? It's 32 feet per second or 9.8 meters per second squared. Depends if English or metric. In this case, we're dealing in feet, so I need to give it to you in feet. Notice that negative 16? Tell me about this parabola. Is it going down or is it going up?
Down.
It's going down. Now tell me about the shape of this parabola. Is it wide, normal, or skinny? It's really skinny because gravity is a big number. How does 16 relate to 32? It's half, and that's the formula. Half of acceleration. Acceleration is gravity. Where do you think the 66 comes from? My speed of my throw. Where do you think the 4 comes from? Where I'm starting. If I was starting on a ladder, maybe I'm starting at 10. I'm starting from the floor. I don't know how you throw it from the floor, but you'd start at 0. So that's where that equation comes from. I don't expect you to know that equation. I'm just telling you more about it. All right? So, here we have our equation. To find the peak, we're going to draw this. Why do you think I put a 4 there?
Show where it started from.
That's where it's starting. I want to find this spot, don't I? What's that spot called? The vertex. What does the vertex lie on? What? Yeah. So if we're going to start this problem, what's the first thing we need to find? The axis of symmetry, right? What's the equation again, Luke, for that axis of symmetry?
X equals absolute B over 2A.
all right? And my values of A, B, and C. If it helps, put them in a little box here. What are my A, B, and C? Negative 16, 66, and 4. All right, let's plug it in.
So negative 66.
Negative 66 over
Negative 32.
2 times negative 16. I'm going to need a calculator here, folks. I can't do that in my head. It's a little over 1, but it's not quite 2.
2.0625.
2.0625. 2.0625 what? What does x represent on the horizontal, you think? This represents the what?
Height.
The height. What's this represent? Well, distance is height. That's okay. It's okay. What's going on when what are we doing? I throw it, and I do what? Look at this variable. What do you think T stands for? Time. T is time. Are we talking minutes, hours, or seconds? Seconds. So this is 2.0625 what? Seconds. How long does the ball basically stay in the air? Think.
2 seconds.
No. Think. How long does the ball about stay in the air? You got it. Why 4?
Could you double it?
Top is the 2.
Right. Go up to 2, fall back down. Exactly 4? No, but good estimation. All right, now I want to find that peak. How do I find that peak?
Then you have to find
I have to find the what?
the y-intercept.
The vertex. Right? I got to find that peak. So let's think here. Wow, I'm going to need a calculator. 2.0625 squared plus 66 times 2.0625 plus 4. Plug that in, everybody. Crunch it out. See what you get. Can't do this in your head. This is where you need a calculator. These are the uses of a calculator in terms of its real use, to do technical stuff. Don't round this. Leave that out long. I want to know what is the height of our ball at the top of the field house. When you get an answer, holler it out, and we'll make sure we confirm it. Josh?
72.0625.
I have one answer at 72 point what?
0625.
Yep.
I got 2 people. Everyone crunch it out. Make sure you get that. I'm hoping it's right. So what do you got? You know how to plug it in? Just take that equation and plug it in right there. All right, there. You get it? 72 what?
No, that's
72 feet. 72 feet. Does it say to round to anything? How long will it take to reach maximum height? About 2 seconds. How far above the field house floor will it be? 72 feet.
that's easy. Except for
This is a realistic application of parabolas, isn't it? Okay. Very realistic. Something you learned today? Gravity. Maybe you didn't know gravity before. Okay. All right.
32 feet per second.
32 feet per second squared. So there's our homework at the bottom.